Sine and cosine, let's talk tangent. So if you notice, the tangent graph is pretty different from sine and cosine, which you guys did. So let's talk about the characteristics of the domain, the range, the y-intercept of this graph. So, I know this graph has vertical asymptotes, and so that means there are a lot of places where tangent of x will be undefined. So let's talk about the pattern that we should notice about when this function is undefined. Let's say we have a vertical asymptote at x equals negative, it looks like 5 pi divided by 2. Cool. It looks like I have another one at x equals negative 3 pi divided by 2. It looks like I have yet another one at negative 1 pi divided by 2. Oops, divide by 2. It looks like I have another one at x equals 1 pi divided by 2. And hopefully you guys are picking up on what I'm laying down here. That one didn't work. That's okay. All right. So x equals 3 pi divided by 2. X equals 5 pi divided by 2. Right. So those are all the locations where I'm going to have a vertical asymptote, aka where my tangent function will be undefined. So let's try to summarize this. Hopefully you notice that it's wherever I have a pi over 2 reference angle, and the numerator has to be an odd number multiplying that pi. So here's how I would recommend you write it out. Your domain is all real numbers except throw back to integrated 2 reasoning and proofs. 2n plus 1 pi divided by 2, where n is an integer. Right? If you take any integer, plug it in for n, and evaluate it, you should always come up with an odd number. And if not, pause the video, try it out, verify it for yourself. The range, however, since we're going from a negative infinity all the way to a positive infinity because we have those asymptotes, tangent could equal any specific number. So notice how it's a little different from the sine and cosine graphs. And I also know that we have a coordinate at 0, 0. There we go. Right there. For the y-intercept. So these are characteristics you should know about the tangent graph. So now let's talk about some of these transformations. Let me clear off a little bit of the screen. Let's get rid of all these asymptotes that we identified. Okay. So if you're okay with the sine, you're okay with the cosine. Now let's talk about the effect that A has on the domain, the range, or possibly the y-intercept. But it would help if we had the graph up. There we go. Now in blue. So if I let the A slider continue, all it's doing is that it's just vertically stretching that graph out in a positive direction. So notice how that's all it does. If I change it so that way it becomes negative, so negative 10 to 0, lo and behold, it's a reflection over the x-axis. So remember how I told you with the sine graph, it looks like it's a reflection of the y-axis? It's not. It's always a reflection over the x-axis. That's what the negative multiplier does when it's outside the parent function, right? And just like before, if we keep it from like -1 to 1, go up by 0.1 with gradual steps, look at what's happening to the graph, right? That's why we would call these horizontal compressions. And if they're negative, call them vertical compressions. And if they're negative, they're vertical compressions that also have a reflection over the x-axis. And I'm showing you how I'm typing this in, so if you want to play with this on your own, you're more than welcome to. All right, but let's make a equal 1. All right, so now we're back to the parent function. When you talk about d, think about what's the only thing that would absolutely have to change between the domain, the range, and the y-intercept based off that d value. And that should help you when you're talking about the sine and cosine, because you want to keep track of what the a value does, what the d value does for the ranges. And since this range is infinite, doesn't matter, doesn't change the range. But it would dramatically change the range for the sine and the cosine if you move the graph up or down, and then from there, you also kind of stretch it out. All right? Hope this helps.